just a template. It's a cookie cutter. D1 and D2 are actual cookies. They actually contain values. They can be eaten. Okay? But date itself is not a cookie. It is a cookie cutter. It determines the shape of cookies. Are we doing okay so far? You know, the distinction between a cookie and a cookie cutter. Is that okay? Can you eat a cookie cutter? No. That means you cannot compare a cookie cutter to another cookie cutter. You can do something with cookies, but you cannot do that something with a cookie cutter. The job of a cookie cutter is what? Cut out cookies, making sure the cookies all have the same shape. And it is exactly serving that purpose here, because when we stamp the cookie called D1, we use a cookie cutter called date. When we stamp the cookie D2, we also use the same cookie cutter called date. That made sure that D1 and D2 have exactly the same shape. Okay? Now, when we talk about shape in programming, we are talking about D1 now has year, month, and day of month. D2 also has year, month, and day of month. Okay, is that making any sense so far? Okay. Let's go ahead and write a program and trace it, just to see, you know, how we can utilize, you know, this new construct that we are talking about. And we'll go ahead and trace it. Okay. And once again, you know, we are just building this kind of concept on top of what we know already. So this is nothing truly new. It is slightly new, but not entirely new. So we'll go ahead and this time we'll just define a complex type. Does anyone know what is a complex number? Okay, yeah. So one person knows what is a complex number, which is fine. It's not a problem. You know, we just have to define, you know, what a complex number is. It has a real component, which is a number. It has an imaginary part, which is also a number. And I have to turn off the autocorrect feature. And in the replacement table, I have to look for I and turn it off. I is imaginary, you know, it is also a number. And this is my definition of a complex number. And what I want to do is to say, what happens when I add a complex number to another complex number? I just want to define the behavior. So for those of you who don't know what is a complex number, just look at the definition of the subroutine. Don't get bothered by the actual, you know, concept of adding a complex number. So in this case, I need two parameters passed by value. I'll just say, you know, the first one is x, the second one is y. And now that we have the notation of a type, let's go ahead and specify x is a complex number and y is also a complex number. In other words, I'm using the cookie cutter now. I'm making sure that the cookie called x and the cookie called y have exactly the same shape. I can pass by reference my result, okay? So I'll just call this result, which is also a complex number. And the calculation is really easy. The result, the I of the result, the imaginary part of the result, is the summation of the imaginary part of x and y. So it's x dot I plus y dot I. The real number portion of the result, same thing. It's just the summation of the real part of x plus the real part of y. And that's my subroutine. Do we have any questions about the subroutine itself? Questions? Okay. So now I'll go ahead and define the main subroutine, which has a local variable. We'll call this local variable w, which is also a complex number. Now, before I do anything else, you know, I should, you know, initialize w first. Well, let's make a few, you know, w, x, y, z. Let's make a v, which is also a complex number. And we'll just go ahead and make another one. Let's say Q is also a complex number. So before any calculations, I have to initialize these local variables. Okay, so I would say w.I starts with a value of 2, w.R starts with a value of 6, v.I starts with a value of -2, and v.R starts with a value of 3. And then we'll go ahead and invoke the subroutine add complex. And then we specify the parameters. Now here is the funny part. Okay, here's the part that makes records worthwhile. When I invoke add complex, how many parameters is it expecting? It's only expecting 3 parameters. Okay, so that means I only have to specify what goes into X. Let's say V goes to the X, and W goes to Y, and I use Q to specify the result. Okay. And define sub, invoke main, and now we have the entire program. Do we have any questions about the program itself before we start to trace it? For the most part, this program is just tedious. Okay, the new concept that we are dealing with is basically a packaging technology. How do we package multiple items into one single item? That's basically what a record does. Which means when we trace this program, it's going to be kind of tedious. Okay, we don't have any comments here because we don't have a single conditional statement or print statement. So we'll start with line number. There's nothing to say about the precondition because we don't have global variables anymore. The first line to execute is line 22, and it invokes main. So we need to specify return line number, and post is the return line number. But now we have to somehow be able to represent what is W, what is V, and what is Q. They are not single columns anymore, right? Because if you look at W, W is a complex number. When you look up the definition of complex, it has 2 individual fields. Each field, in this case, takes up 1 column. So that means when we need to represent W, V, and Q as columns, we have to say that the W now consumes 2 columns. Because W has an R component, W has an I component. Same thing goes for V. V has an R component, V also has an I component. And the same goes with Q. Q has a R component, Q now has an I component. So with 3 local variables, W, V, and Q, we are now allocating 6 columns. Are there any questions at this point about why we have 6 columns instead of just 3? No questions? Okay. So just to make it more clear, I'm going to merge these cells just so that you can visually see that both column C and column D specify W, both column E and F specify V, and both column G and column H specify Q. Haven't we seen something like this before, combining multiple columns and give it a single name? Don't we have arrays before? Now this is different from array. How do you specify a particular item in an array?
Index.
With an index, a number, right? It's 0 up to bar A bar minus 1 if the array is called A. But in this case, there are no numbers. They are identified by names. Okay? In other words, column C is the R field of variable W. Column D is the I field of variable W. They are not numbered anymore. Okay? So they are different things. Arrays and records are entirely different things. They can kind of coexist peacefully, but they are different concepts. Now that we have all these columns specified, we can continue execution inside the main subroutine, which is starting on line 16. Okay, so line 16 is not a problem. can we find which column is w dot I? Sure, column D is w dot I. Line 17, I mean, this part is just tedious. Line 18 deals with v dot I. That's -2. And line 19 deals with v dot R, which should have a value of 3. Are we okay with, yep, go ahead.
So before row 5, line 16 there, you don't need to put question marks?
Yes, I do. That's it. Thanks for the reminder. I forgot about that. These should all be unknown because they are all local variables. Thank you. Thanks for the reminder. Very good. Good job. Okay. Does everybody get that part? I forgot to specify because each field of each variable is a single column, and because of the local nature, they start with unknown values. So this is actually what I should have done, but I forgot to do it. So we're up to line 19 right now, and Q still has unknowns at this point, which is fine because the add subroutine will deal with it. So we are now up to line 20. Now line 20 is kind of interesting because we are invoking add complex, and we are passing v and w by value, but q by reference. So now we get to see what do we have to do to pass a record by value. So we'll go ahead and specify these columns. First of all, we have return line number. The return line number is going to be 21 because the invocation happens on line 20. That's the easy one. Then we have to specify the parameters. We have parameter x, we have parameter y, and then we have parameter result. And just from the allocation of the columns, you already know what x has. X is a complex. So x has two components. It has the R component, it has the I component. Now why do I know that x has the I and the R component? Because of the type. Okay, parameter x is a complex number, and the complex number has a R component as well as an I component. Okay, it's the same thing with y. So y has an R component, y has an I component. What about result? Result is a little bit strange because result is passed by reference. In other words, we are still keeping result as a reference to some columns. So that makes result an alias of column what to what. It's a reference to column G to column H. Is that okay? We have just extended the concepts of passing by value and passing by reference from single values to record types. Okay? But the mechanisms have not changed. Passing by values is still making a copy of the original item. Passing by reference is still passing the reference to the original columns and instead of a single column. So I'm just going to combine these to make it more clear. Now what do I specify here? According to this code here, I use v to specify x. In other words, parameter x is an exact copy of local variable v, which has 3 as the R component and -2 as the I component. I use w to specify y. W has 6 as the R component and 2 as the I component. 6 here, 2 here, and 3 here, 2 over there. Are we doing okay so far with this program?